Welcome to your first step into basic electronics. Today, we're going to learn how to use simple code to control the physical world around us. This is how we naturally interact with our environment. When you reach for something, your eyes send a sensory signal to your brain, and your brain processes that information to tell your hand how to move. Electronic automation relies on this same logical loop. By swapping these biological parts for electronic ones, we allow a machine to sense, think, and then act. To handle the thinking part of that loop, we use an Arduino. It's an open source platform, which means it's a simple, accessible digital brain designed specifically for beginners to experiment with. Understanding how this one board works makes the bridge between writing software on a screen and moving physical hardware in the real world much more direct. Let's look at the physical board. This layout shows the different zones of an Arduino, and we can map them right back to our human body metaphor. Right in the center is the microcontroller. This is the brain of the operation. It's the component that processes the information and follows your instructions. Along the outer edges, you'll see two rows of small sockets. These are the connection pins, divided into analog and digital sections. These pins are like a nervous system. They carry electrical signals back and forth between the central brain and the outside world. The analog pins work like our eyes and ears. We use them to connect sensors that read continuous information, like measuring how much light is in a room or checking the temperature. The digital pins act like our hands and feet. We use these for parts that take simple on or off action, like turning a light on or telling a motor to spin. Finally, we have the USB port. This physical pathway is used to give the board power and teach the brain new instructions from your computer. But all of these connections remain an empty shell until you actually teach that central chip how to think. Step 1 is programming. You use a free tool on your computer to type out commands. Think of these as a specific set of written instructions using words the board is designed to understand. Step 2 is uploading. You take the instructions you just wrote and send them from your computer through the USB cable and directly into the microcontroller's memory. Step 3 is execution. Once the instructions are sent and the board has power, it can work on its own. It will run your instructions on an endless loop, constantly sensing, thinking, and acting. This three-step cycle, writing, sending, and running, is the same basic process used to create nearly every automated system you encounter. This simple brain is the engine behind the smart devices we see every day, and you can apply it to almost anything. You can build smart home systems, like a sensor that turns on the lights automatically when someone enters a room. You can create security setups, like building electronic door locks that trigger based on sensor data. You can dive into robotics, using the board as the logic center for a mechanical arm or a rover that navigates around obstacles. It's also useful for environmental monitoring, like a system that checks if your plants are thirsty and automatically waters them for you. Or you can use it for creative design, making interactive art that moves or changes color when people walk by. Whether it's for household chores, robotics, or art, one basic board provides the foundation for endless applications. While building smart technology might seem out of reach, Arduino was created to lower those barriers. While the complex chips found in high-end factory machines can be expensive and hard to find, Arduino boards are made to be affordable and widely available online. Because it's so popular, there's a massive community of people sharing free tutorials and helping beginners solve problems. If you ever have a question, the answer is usually just a quick search away. You don't have to be a professional engineer to start creating your own electronics. The tools are ready for you. It's just a matter of deciding what you want to build first.